SynCity AI is an AI-powered model, which uses IoT components, wireless sensing, rapid AMD processors, forecasting algorithms to predict and manage the usage of various resources like electricity, water, waste, security, and manages them efficiently, thus revolutionize the concept of smart cities. Here is a 3D Blender model, which showcases a smart school environment. Here is the working of the project. The school uses various sensors to get different values and stores it in a database. Using these data, with the help of linear regression forecasting, we can predict the amount of electricity water needed for daily usage and automates the processes. The predicted values will be shown in a dashboard for ease of use and understanding. Here we are using ultrasonic sensor to measure and predict both waste materials level and water tank capacity. The ultrasonic sensor measures the water level and send the information to database using Wi-Fi technology. Then this data can be visually represented in dashboard, and with those data prediction, water management can also be done. When the water level reaches too low, the model automatically detects it and refills the tank, which is architecture is shown in the later part of the video. Now let's get to temperature sensor and electricity management. The temperature sensor senses the temperature, and its reading are stored in a database, which can later be used for both prediction and visualization purposes. When the sensor detects a spike in temperature, it outputs more electricity to the fans to spin faster or switches on more fans to cool the place and keeps the students comfy. Its architecture will also be shown shortly. This is the master dashboard, which performs and showcases forecasted predicted values and real-time data with the help of high-powered and high-processing AMD's accelerated processing units APUs. This project leverages the functions of a smart city and automates it while managing the resource efficiently. Utilization using past data and forecasting models, along with that, provides an ease to monitor dashboard and simple visualization technique. Now let's get to the part of IoT architecture and coding. Since we doesn't have any hardware components, we decided to use Tinkercad to simulate the working. This is the architecture of electricity management, where we used LCD display instead of dashboard to show the current readings, and these values then be used for forecasting. Since we doesn't have any power fluctuation here, we are using a potentiometer to vary the current, and the values are reflected in the display. In real application, the current usage is measured and stored using MongoDB, which is displayed in the dashboard for monitoring. Here we have integrated the temperature sensor with electricity management. When sudden spike in dashboard occurs, we can get to know that there is an outburst and safely turn off the circuit. Here the display indicates the dashboard, and the LED buzzer indicates various electrically powered objects, like fan, AC, cooler, heater. When the temperature sensor senses more heat, it automatically allows more current to flow to cooling devices to maintain the temperature. When we increase the temperature value, we could see the change in value in the display, and when the current reaches certain point, we can see the LED and buzzer triggered. Similarly, more power will be given to the electrical components to maintain the temperature. Both the water and waste management systems works in similar way, using ultrasonic sensor to detect the level of waste and water. Then their values are shown in dashboard, and data read using this analysis can be used for future need prediction and helps in efficient resource utilization. The main difference between these two is that waste management is triggered when a bin gets full, and when needed to be collected, it sends the signal to empty the bin. Whereas in the case of water management, the sensor sends a signal when the water tank is empty and the motor is turned on autonomously and refills the tank, and again sends the signal to turn off the motor when the tank is full. In this case, motor is represented using LED. Since motor is not available in Tinkercad, we can clearly see in both the cases, change in distance on ultrasonic sensor triggers LED to glow, and the readings in board is also getting changed. We used both ultrasonic and PIR sensors to detect motion and security. These sensors are placed in smart doors and gates for security management and motion detection. When any anonymous motions are detected, the sensor senses and send a warning signal to the dashboard. In this case, LED light indicates warning trigger. When any change in motion detected in PIR sensor, the LED blinks and send a warning signal. In case of ultrasonic sensor, the sensor senses and automates opening and closing of doors, thus maintaining security standards. Here is the design of the dashboard, which displays various details of the campus and provides alert system. This dashboard visualizes the data collected by the sensors and processed using linear regression forecasting with the help of high-processing AMD chipsets, thus enables a full control of the campus from one place. Now we will have a full look at codes used in this model. Code for each of the sensors along with their circuit image is shown. The code for dashboard and linear regression forecasting are also stored in the names of SynCity AI, .zip, and linear regression forecasting.py respectively. Thank you AMD Slingshot for this opportunity.